Okay. All right, I'm going back to where I was. Okay, I think we should be good at this point. So we're looking at the website, and I think I called your attention last class to the calendar. And here we are on Wednesday, the 14th, and we're trying to complete chapter 2, and we'll review on Friday, and then take that first exam on the two chapter 1 and 2. But somewhere I'm hoping this is what you needed. There were test reviews. Is this kind of where it was? Chapter 2 review, maybe?
Yeah, that's where it was.
Okay. So this is a perfect place to work a little bit. You're asking me about number 7, so I'm going to see. Okay,
It wasn't the same numbers.
it's different numbers, but
Yeah.
it's the same idea.
Well, for mine, I feel like I got it right.
Can you tell if it's the same type of problem or not? Do you have yours written down? Because I could write yours down on paper.
Mine is 4 5/6 divided by 2 3/4.
2
And
3/4,
yeah,
and that's all?
yeah.
Okay.
And they said to leave it as an improper fraction.
Oh, very nice. Okay. So this is not a bad problem. I'm going to do this and the other one. Did anybody have any other? I guess basically what we've just figured out is that the problems that I bring up are different than the problems that you bring up. So you're going to have to tell me the exact wording of the problem you're having trouble with. Did anybody else have another one from this section that we could do? Okay.
For me, it's some of the questions when they I don't know. I have to look at. Let me look at the. I want to say it was 2.4, 2.3. It's
yeah, that's what I need is like the exact one you had, and then
is it okay if I just go to the home real quick?
Yeah, why don't you do that? And I'm going back to the paper and do a couple of these problems. So yeah, when you figure it out, let me know and got it. Okay. Okay, so this was one problem that we were asked to do, and the instructions were different. They said you could leave it as an improper fraction. So that's okay with us. But here's the deal about division. Division and multiplication are tied in the sense that you do them in a similar way. But the first thing you do is make sure that the division problem is converted to a multiplication problem. So if you remember with fractions, they didn't like the computation to involve mixed numbers. They wanted that improper fraction. So I would go 6 times 4 is 24, plus the 5. 24 and 5 is 29, divided by 6. You keep the denominator. And then this one, let's do the same thing, get this in good form. 4 times 2 is 8. 8 and 3 is 11 over 4. So what I have is a nice looking division problem. It's in good form, but there aren't rules for doing division per se. And so what we do is we convert this into multiplication. And in multiplication, this is 29 over 6 times, make sure we can see that. This gets inverted. This is the only thing strange about division. And in a minute, I'll give you an example to show why this works. But for the time being, I want to just complete the problem. At this point in time, you can totally forget anything else. Just ignore everything. You know what I'm saying? This is your problem now. And so that's the problem you want to be doing. So the only thing I can see that we could improve upon is we could reduce the 4 and the 6 because they both have a factor of 2. And if you're okay with this technique, divide 2 into 4, it's 2 times, and divide 2 into 6, it's 3 times. And at this point in time, there's nothing more to do. So I'm just going to multiply across. 29 times 2 is 58. How did I know that? 3 times 11 is 33. Okay.
I got that same answer and it told me it was wrong.
You're going to have to reread the instructions. Maybe it said not to use an improper fraction. Because so far they have made us convert these all to mixed numbers. And so if that's the case, we just have to do it. So this part here would be 33 into 58, and it's only going to go once. 1 times 33 is 33, so that's 25 left over. There's no more to do, so I have 1. The remainder is 25 over the divisor, or this number here, which is 33. So I'm betting that if they won't accept that, they would accept that.
Professor?
Yes.
So I ran into the same problem on some of those questions. And then
Yes.
just out of curiosity, I tried like reducing it without making it into a mixed number. And then though they would accept those answers, which was weird, right?
I did the same exact thing.
Okay.
I thought I discovered fire the way I found that answer. You know
Right?
what I mean?
Right?
I'm not kidding. 'Cause
So
I'm
let me
sitting
make
here
sure
like,
I
maybe if
understand
I
what
do
you're
this.
saying. So
Yep.
if you didn't
Same.
reduce it, they accepted that answer?
Yes. Yeah.
Yeah,
Oh,
like I
what? They're
reduced it.
so wrong.
Yeah.
I reduced it, and I did the same thing. I'm sorry, I didn't mean to interrupt you. I reduced it, and
Yeah.
in
Like
one of the
this?
questions, and I got the right answer, and I didn't reduce it the same way. Same answer I would have got this way.
Okay.
Without, you know, it's just the program is weird because
Yeah, there's
you know,
something wrong. So what you want to do, of course, this is the advantage of me grading your work, because then it's a human being instead of a machine. But if you have a problem like that, inside XYZ, go to messages and tell me the exact section, the exact problem, because I can go into your work and I can try it myself. I want to see exactly what you're saying. And I understand what you're saying, but I need to see it. And then I'll try to figure out what we need to do. Okay? Because not reducing it is not a good plan. I mean, look at this. This would have been 29 times 4, which would have been considerably larger. This would have been 6 times 11, considerably larger. Reduced is much better. And so I need to kind of just show me the ones that you had trouble with, and I'll go into your homework. Okay. Thank you very much for that, because that's totally unexpected. This was the problem that we pulled up when we were looking for the other problem. And so let's just go ahead and do it. This is saying the quotient of 28 and 74 is increased. That's the word, increased by 11. So this is about a quotient. And so quotient means divide. So these are the two numbers that have to be divided. So this is 28 divided by 7/4. Okay. Now, the next part of this is the word increased. This is one of the words for addition. So if you increase what you have, you add. So then you would have to add 11 to that final result. Does that make sense? So it's quotient, which we know is divide. These are the two numbers. The order is exactly the way you see it. And then the last part is increased by 11. So I don't know if they just wanted you to write the problem or actually do it. But I think now that we've gone this far, let's just do it. This is division. This is addition. Division is more important in the order of operation. So I need to do this part first and add last. So this is 28/1 divided by 7/4. I'm going to ignore this for the moment. It's now simple fractions, simple fractions. The first number is never changed. Division is converted to multiplication, and this gets inverted. I'm going to have the 4 and the 7. So what I need to do is see if I can't reduce this. And so 28 and 7 could reduce by 7. 7 goes into 7 once. 7 into 28 is 4 times. So what I have with this is a 1, that's a 1, but this is 4 times 4 is 16, and 16/1 is 16. If I could write it over 1 right now, but it's going to be 16. Is that okay? And then I have this last little bit to complete. There was this increased by 11. So in this particular problem, I would add it to 27. I couldn't do any more. So it all depended on the instructions, if they wanted you to actually solve it, or if they actually just wanted you to rewrite the problem. And see, here's why word problems are trouble. This is English. Now, you may or may not love English, but English is a language. When we convert it to this, we've converted it to a different language. This is mathematics, which is a language of its own. I've been in classes where students were from all over the world, and English was not their first language. And yet, once we got to the math, everybody could understand it because they understood the language of math. Okay? So there's a problem. English, who cares? Math, that's what we're interested in. And so if you can get from here to there, then you should have a good chance to do it. Does that make sense? I wanted to show you really quickly about the division and why you have to invert. I'm going to do this with food, and I'm trying not to eat. But here it is. If I had 10 cookies and I had 5 people, could you figure out how to divide these up fairly? Right? And so it's 10 divided by 5. And so everybody would get 2. Let me try a different problem. I have 10 cookies and I have only 2 people. I'm trying to decide how many each person gets. I can think of 2 perfectly good ways to get this. One is division. 10 divided by 2 would be 5. But there was another way to do it. And the other way was using multiplication. If I take 10 and multiply by what? How could I still get the number 5? 5 is the answer. They're good cookies, by the way. How about if I multiply by a half? Would I still get the right answer? What I'm trying to say is division by 2 over 1 will get you the exact same answer as multiplying by 1 over 2. So I want a half of the 10. Each one gets a half, right, of the total, which is 5. And so I want you to see that the division went to multiplication, the 2 over 1 went to 1 over 2. Whether you like my cookies example or not, I don't know, but it works mathematically, and so we're pretty happy with that. And so that's why division, we're always inverting. When it's fractions, we're always inverting that second number. So did anybody find anything else while we were, I know people were looking for different problems. Could somebody give me the problem or any? Yeah, does somebody have something? I thought maybe somebody was looking.
I have one in the chat
Okay,
for you to look at.
okay, because I'm
I
at the
got one
moment, I
after.
can't see it. So can you tell me what it was?
It was reduced to lowest terms, 130 over 90.
Okay. Okay, I think I can do best with paper. And so the thing about this one is there's a really easy start to it. If you divide by 10, 1 0 goes away. And divide this by 10 and 1 0 goes away. So many have learned to do it like that. And your answer is now done. 13 over 9. Now, it all depends on what the instructions are and if the website is working correctly. Did you try putting in a certain answer?
It just say reduced to lowest terms, but I had a
That
lot
is
of trouble with
reduced
that.
to lowest terms. So the question is, did the answer accept that? Is that what you put in?
Actually, I have to go back to the screen. See what I put in.
You're not sure what you put in?
I don't think I
Okay.
put in that though.
Oh, you don't think that was this? Do you think
No.
it might have been 1 4/9? Which would have been the,
No, I actually think I used a fraction.
oh, yeah.
But that's good to know the procedure you used there.
I want to give you some others. I want to just show you about the zeros because this is a handy thing that doesn't require a lot of thought. This number has 2 zeros, this has 1.
Mhm.
I can reduce this because they both have at least 1. I can't take 2 for 1 here, but I can take 1 here and 1 here. So then this becomes 40 divided by 6. See, that cuts it down to a decent number. This is not complete, but it certainly is much better than the original. And then I think I might divide by 2. 2
Yes.
into 40 is 20, and 2 into 6 is 3. See, I got that down to size pretty fast by taking the zeros out.
Mhm.
Okay, and then this could either go to a mixed number or not, depending on the instructions. 500 divided by 700. Technically, what I've done is divide by 100. And so this only works with zeros, so don't try it on anything else. But dividing by 100, 500 divided by 100 is 5. 700 divided by 100 is 7. We're done. How's that? I
One
see no
question.
trouble. I see no problem in making that harder than it needs to be.
I have a question.
Okay?
Where you have 20 over 3, is
Yeah.
that the answer?
Well, that
You don't
depends
flip
on
it.
the website.
But you don't flip it, right?
No. The only flipping is done with division, and it's
Okay,
the second number.
okay,
And there's no reason to change anything. And so this one, it's just divided out. 3 into 20 goes 6 times. There's 2 left over. And there's nothing more to bring down. So the answer is 6, remainder 2 over 3.
okay.
So we're dividing by 3, and that's, we did it out in the problem. You don't have to do it out because it may work to just do it in your head, okay? Anybody see another problem before
I did. If a
Go ahead.
gallon of gas costs 333 9/10 cents, how much does 1/3 of the gallon cost, or gallon cost, right?
Okay,
I worked on this for a long time and I got it wrong. So I just want to figure out what I got to do to keep
so, so this one here, was there a decimal in this or not? No.
No.
So it was 333 and 9/10, right?
Yes,
I got the
ma'am.
number right?
Yes, ma'am. Yes.
Okay, so this represented 1 gallon, right?
Yep.
So these are kind of silly problems, but anyway, this goes with 1 gallon. There's no doubt about it. So the question is, what about 1/3 of a gallon? Now, you can
figured
do
it's
it through
division.
multiplication. We want, if I bought a gallon, I'd pay this and that's the end of it, right? Because that's the cost. But I only want 1/3 of it. Literally, I want 1/3 of the gallon, right? The word of means multiply. So here's one approach. I have 1/3 times the cost of the gallon, which is 333 and 9/10. Can you see I'm not going to pay for the full gallon? I want 1/3 of it. 1/3 of that cost of the gallon. And so literally it's 1/3 of this cost. And so they kind of stretch making a strange problem.
That's what I think got me, is because of the fact that I know so
You know what
1/3.
a gallon of gas costs. This is nowhere near right.
No, 1/3 times it. So I know it'd be 3,339 over 10, right?
Yes, so you almost have it. So
I knew that.
333 times 10, 333 times 10 is 3330. Plus the 9, I don't know if you did the plus the 9.
Yeah, 3,339. That's what I said. I cut out.
3339. So it's 1/3. We'll just do it. 3339 over what number?
30.
No, that's your problem. It's over the denominator 10. The denominator is copied. So when you multiply this, it's this times this plus that, we got it, over the 10. Let's finish it off because we're nearly there. We've done the hard work. The 10 and the 1, there's nothing I can do for it, but I think I could reduce the 3 with all of that, because 3 goes into all of those numbers, doesn't it? So 3 goes into 3 once, and 3 goes into this. I think I can do it in my head. 3 goes into the first 3 once, and 3 into 9 is 3. Now, if you didn't like that, doing it in your head like that, you could do it on the side and then bring it in nice and neat. But this is now reduced. So it's 1 times this crazy number, and I'm going to write it down, 1113. The denominator is, this was a 1 times 10 is 10. So here's the improper fraction reduced. Now, it seems like they just love mixed numbers. So be it. So that's 10 into this 1113. I think what they're trying to do is get you to practice your division. I don't know. But 10 into 11 goes once. This is 10. 1 left over. Bring down. 10 goes into 11 once. 1 times 10 is 10. Subtract 1. Finally, bring down. 10 goes into 13 once. 1 times 10 is 10. 3 left over. There's no more to do. So the answer is, let me just bring it so you can see it. 111. Remainder is 3 over what number?
10.
Correct.
Yeah, I didn't have that.
Did you miss one little spot? I don't blame you if you missed one little spot. The trouble is, this problem would have been so much easier with decimals. But we'll do decimals after fractions. So they need you to feel like you can do fractions even if you don't want to. And after that, then we'll do decimals.
For me, I think it's just the irregularity, excuse me, not irregularity, the numbers. It's just the
It's so
how-
impractical.
589, 3,300. It's like, geez, these could be so simplified. Like as far as you know, the steps, it would make it easier. But you know, it can't be that way.
Yeah, that's right. And so this is, but they're trying to force you to practice. And so I can appreciate that part against your better
Me too.
judgment. I know what they're doing, but hopefully it's okay. So was there something else I could look at? Yeah.
I had one more, unless someone else
Go
has
ahead.
something. Then
Well, might as well, because I'm sure everybody needs all this. Go ahead.
It was multiplying 3 different mixed numbers. So I mean, it could just be a random.
Yeah, you can make it up for me. Or if you have something written down, I'll copy it.
I'll write it down right now.
Yeah, I mean, they're just kind of adding to the, making it a little bit harder. Do you want me to just make
Like
one up?
5 over 9/5.
Wait a minute, 5 and 9/5, is that what you want?
Yeah, I'm just making it up, but is it
Well,
okay?
9,
No.
is it times?
Yeah, I said to divide times. Sorry.
5 times 9/5. I'm going to do it like that.
Yep. Oh,
Want some more?
it was. I'm sorry. I put like. Oh, okay. Hold on. I'm confused. No, it would be like 5 9/5 times 6 8/4.
Okay, so they wouldn't write 5 and 9/5 because 9/5 is improper, and then putting it with a
Okay,
mixed
hold on. I'm
number, they
already.
wouldn't have-
I'm sorry.
But
Yeah.
I can make up one that'll 4 and 2/3.
I don't think he wants the multiplication there, right?
Do you want division in
It's
here?
the second one. No, it's the second one. So it's 4 2/3, and then like 2 more just like that. You know.
Okay, I got it. All right, I'm gonna start over. 4 and 2/3. You want division or multiplication?
Multiplication.
Okay, times 2 and 1/7 times 3 and 1/5.
Thank you
This
so
could be a
much.
heck of a mess. You ready for it? Because it's all multiplication, we're going to not invert anything. We're just going to make all these proper fractions or simple fractions. Okay, so let's proceed. I have no idea what's going to happen here because I made it up. So 4 times 3,
12.
12 plus 2,
3.
14 over 3, right? See, it's over
Yep.
that denominator, over 3. Next one,
2 times 7 is 14 plus 1 is 15/7.
okay.
And then it's all 15 is awesome. The next one is 16/5.
Okay. Actually, I didn't do so badly. I was hoping something would cancel, and it will. So even though there's 3, these 3 are numerators and these 3 are denominators. And so anything from the top with anything from the bottom is fair game for canceling. Do you see anything that would reduce right now so that we don't have to multiply these big numbers?
2 goes into 14 twice. that right?
Yes, the 14 and the
7.
7, that's the first thing I saw.
Yeah.
And
that's
so
all.
they both, so just focus on those 2 numbers. They both divide by 7. 7 goes into 7
Once,
once, 7 into 14
twice.
twice. There's more.
3 into 15.
3 oh well, 5 3
So
5
3 and 15 or 5 and 15, I don't care which one. Do you care?
No.
It doesn't matter. So 3 goes in, I'm going to do 3 and 15, but I could have done this one as well. 3 goes into 3 once, 3 goes into 15, 5. Anybody see anything else? Because we're not done yet. It's a good problem. I've made up.
5 and 5 maybe.
The 5s are 5 here and 5 here can reduce by 5. 5 goes into 5 once, 5 goes into 5 once. Now, I know I'm done because the denominators are all 1, 1 and a 1 and a 1. So there's no, I don't have anything to go anymore. So what I have to do is multiply across. This is a 2 times a 1 times a 16.
32.
2 times 1 times 16 is 32. And like I said before, 1 and 1 and 1 multiplied together is 1. So your answer is 32. Simplest
So-
version.
What I wasn't doing is simplifying when we got to the second part. So I've been
And
going
the
crazy
problem
over.
is, look at this, 14 times 15 times 16 is about 1,000 or some stupid number. I don't know what it is. But then if you don't do it now, you're going to have to do it later and it's going to be so much harder. So
Especially
this
trying to
is
get-
the time right here. This is the time for reducing. Now, some people, I'm going to rewrite this problem before we started fooling with it. Once in a while, I run into somebody that just that canceling is killing him. Okay? And so one thing you could do, if the canceling doesn't work for you as you're doing it, you do have the option of breaking things down into factors. And so for instance, and I just want to bring this up for this one problem, 14 is really 2 times 7. 3 is a prime number, so there's nothing to do but say 3. 15 is actually 3 times 5. 7 is a prime number. 16 is a whole string of 2s. 5 is 5. 16 is made up of a whole bunch of 2s, and it's not going to matter, but I'm going to show it to you. 16, 2 into 16 is 8. 2 into 8 is 4. 2 into 4 is 2. So 16 is actually made up of 4 2s multiplied. It's not actually going to change anything, but I'm going to put them in. So you could make a factor tree or whatever, but in the end, it's all 2s. The reason I did it this way is because now I've got what I call the skeleton view of the problem. When you saw the 7 and the 14, it was because they both had a factor of 7. And so in this particular approach, all you do is cancel the same with the same. There's no thinking particularly. It's just same with the same. I could see the 3 and the 3. I could see the 5 with the 5. And in the end, I've got nothing left to reduce. Do you see how this is? That's my own word, skeleton view, but it's kind of descriptive of what you have. You're down to brass tacks. You're down to the prime numbers. And so there's nothing left to do. So the only thing I have left to do is 2 by all of that. That number was 16. 16 times 2 is actually 32. That's the same answer we had. So once in a while, even though I'm pretty good at canceling, once in a while I break things down into prime numbers like this, into factors, and I can see more clearly what needs to be done. Okay, so they brought this up in the chapter, and it's really, everybody's different, and so what needs to be done to get it right is different. But I wanted you to see that because this is clearly, when you bring out that factor of 7, that's clearly why you got away with canceling. Okay. How's that? Did you like that problem? I actually turned out better than I hoped. Okay. So you don't have to do it this way, but somebody might. Somebody in the class might think that's a good plan. Okay, how are we doing? So
I have a question.
okay, go ahead.
Okay, it's 15 over 4
Uh-huh.
times 38 over 23 times 2/3.
Okay. Well, I don't see a lot here. I take that back. I'm starting to see a couple of possibilities. Does anybody have a possibility to cut this down to size a little bit?
15 and 3.
Yes, I do see the 15 and the 3, and I like it.
Mhm.
And so I'm going to divide by 3. 3 goes into 3 once. 3 into 15 is 5, using that method. I can see maybe one more.
2 into
2 and 4.
4.
2 and 4 would be just fine. The 2 and the 4, that's fair game. We're going to divide by 2. 2 goes into 2 once. 2 goes into 4 twice. There's one more. I hope you can see it.
38 and 2, no.
The 38 and the 2. 38 is
Oh.
even. 2 is even, obviously. I'm going to divide both of them by 2. This will help ever so slightly. 2 goes into 2 once. 2 into 38 is actually 19. Now, I don't know if you remember, but 19 is a prime number, so it's going to be hard to get something to cancel with it unless there's another 19 down here, which there's not. It also turns out that 23 is prime, which means there's no way to cancel it unless you have a 23 up here. The prime numbers actually help you see whether you're done or not. And frankly, we're done. This is prime, this is prime, this is prime. There's nothing left. So what you have to do is 5 times 19, 45, carry a 4. Whoops.
No, wait.
5 times 1 is 5 and 4 is 9. So I'm getting 95.
Oh,
And then this is a 1, this is a 23, and this is a 1.
23.
It's 23 when you multiply. And so you know the drill at this point in time. How many times does this go? This was something when they were showing you first division, how you might figure it out. Rounding this to 20 and rounding this to maybe 90. It's like 2 into 9. My best guess is maybe 2 into 9 is 4. I'm gonna do it on the side and see what happens. 23 times 4, 12, carry a 1. Ah, I like it. 4 times 2 is 8 and 1 is 9. It's 92, which is gonna be fine. So I'm gonna put the 4 here. I thought 4 was good, but did you see what I did? I called that 20, I called that 90. And 2 into 9 is 4. It was my best guess. I wasn't too sure about it, so I did it on the side. And then 4 times 23 is 92. I already did it. And there's 3 left over. So my final answer would be 4 and 3 over the divisor 23. There's your answer. How's that? So Kansas,
Simplifying everything it's like literally like you turn on a switch. It makes the
working?
problem so much more easier as opposed to
Yeah.
trying to go from 1,500 to, I don't know, 15,
I have
whatever.
to tell you, I started teaching when I was 22. I've been at it forever. Frankly, I've seen it all. And so I know what works. And if this doesn't work, I've got 5 more ways.
Says it's the wrong answer.
Are you sure it's the same problem? Did they switch it on you? You like how they do?
Oh, yeah, it's
similar?
fine. Okay, no, it's right.
Okay.
I had it on the wrong.
Oh, yeah. That's a little problem right there. Okay. But
Thank
anyway,
you so much.
how is
Seriously.
that? How is this? I think canceling is good. They used to teach it. And then, but then this factors, there's something good about that too, about seeing the numbers. I mean, literally, when you can see what each one really is,
Mhm.
you can see into the problem. I think some people actually saw it without it being pointed out to them, but seeing into the problem, this is why this is going to work, why it reduces down to 2 over 1. Mhm. Yeah. Okay, anything? I was getting ready. Let's see our time. We're getting good. I was getting ready to do.
I have a question for one of those.
Okay, you got one?
Yeah, it's find the area of the length 3 centimeters and the height is 1 1/2.
And it's a triangle, just
Yeah.
like the one I drew.
Yeah,
So the length was what now?
3
3 centimeters.
and the height is
Height,
1
which is this
1/2.
one that's dotted?
Yeah.
1.5
1 1/2. Yeah.
centimeters. Okay, can everybody focus in on that one problem? I'm gonna get a cleaner piece of paper. Okay. So the formula for triangle, and I would write it down somewhere, is 1/2 times the base times the height. This is just what we're doing. It's just applying it to a triangle. So automatically I've got the 1/2 here. Which of these numbers represents the base? The base
3.
is on the bottom, usually.
3.
I got it. 3 centimeters. And which of these numbers represents the height? How tall?
1 1/2.
1 1/2. And it's also in centimeters when we need it. At this point in time, I can forget the poor triangle and just try to do this problem. This is fractions, fractions, fractions. And so this would be, I'm going to keep the centimeters out for a moment. 1/2 times 3, which you know what to do now, don't you? 3 becomes
1 over.
3 over 1. Okay, this is our game with fractions and multiplication. This, we know what to do with that as well. 2 times 1,
There's
2
2.
plus 1 is 3 over what number?
2.
Mhm. That's the problem boiled down. The question is, does anything cancel or have common factors? I'm shaking my head.
No, they're all prime,
Shake your
right?
head. Well, they're all prime, but if we had a 3 here and a 3 here, that would be okay, but we don't.
Right.
We have 3s on top and 2s on bottom. We're not going anywhere. So there's nothing to reduce. So we multiply across. 1 times 3 times 3 is 9. 2 times 1, forget 1, is 2 times 2 is 4. Now, I'm thinking they've made it pretty clear to me that they want the mixed number. So I'm going to give it to them. 4 into 9 is twice, right? You can do it on the side, but it's twice with 1 left over, 1 what?
4th.
4th. So it's the answer is answer is 2 1/4. The centimeters times the centimeters is what?
Squared.
Square centimeters. And every time you have an area problem, it's gonna be square. It's gotta be. Because you're multiplying 1 unit by 1 unit, and that gives you 2 of them, square centimeters. And so it's 2 1/4. How is that one? That was what I was gonna do, so thank you for the problem. What else? I found one weird problem, and I don't know if you've seen it in your homework, so I'm just going to read it to you. It's about cooking.
Oh, yeah.
So a cake needs 3/4 of a cup of sugar. Okay, that's about right for cakes. Now, if all you have is 1/8 of a cup, my first thing is go buy some more measuring tools. But let's face it, we don't have it. So the question is, we have a 1/8, which is kind of small. 3/4 is a fair amount. And so the question is, how many times would we have to fill this to get it up to 3/4? And so the problem is actually, can you convert one to the other? In other words, can you make equivalent fractions? So 3/4 is what you want. Otherwise, the cake won't be just right. But we have to do it in 8ths. So here's one approach that you might consider. Can you make this equivalent? In other words, this is one thing that you have the skills to do. 4 times what is
6,
8?
8,
4 times what?
6.
4
Eight.
times 2
Oh.
is 8. And if I multiply this by 2, I have to multiply this by 2. 3 times 2 is 6. So this was one approach. It may not be the approach they used, but it was the first thing that I thought of. If I would convert this,
Right.
the 3/4 will be 6/8. How many times would I have to fill this up? How many 8s would I need?
6.
I'd need 6. I have to do it 6 times because this number and this number are equivalent. 3/4 and 6/8 are equivalent. It was easy to get 4 into 8 by just doubling both. And so now I'm thinking, 1/8 won't do it. I've got to do it 6 times to get it right. This happens a lot in measuring where you don't have quite the right tool. But the fact that all you've got is 1/8 is kind of a pitiful thing. You've got to fix your kitchen. The other,
Miss Patterson,
There's another way to do it by division, but go ahead. Mhm.
I actually have like trouble with a certain type of problem.
Okay, what is it?
So it's 4 divided by 2/3 to the second power
Okay,
plus
thank you. 4 divided by 2/3 to the second power,
yes.
like that.
Yeah, then plus 18
Oh, okay. Is there any more? Or is that it?
plus 18 to 3/5 to the second.
Another one, in other words, like that.
Yeah, it's the same problem.
So tell me what's right here. 3/2?
2/5.
2/5 to the
Oh no,
second.
3/5, sorry.
Okay, 3/5. Mhm.
To the second power.
Okay. Okay, so I know we're kind of running out of time, but I'm going to try to finish this. Remember order of operations, what seems to be most important here?
Exponent.
Exponents. So I'm going to do this a little bit on the side and bring them in the answer really nice. 2/3 squared. It's real easy to make a mistake with that, but there's no canceling, so you just have to multiply it across. It's 4/9. So this becomes 4/9 right there. This is 18. And what I need to do is do 3/5. So 3/5, I got to do that next because the exponents rule. So 3 times 3 is 9. 5 times 5 is 25. So this became 9/25. Are you sure this is the right problem? It's kind of awkward.
Oh, the 18 is supposed to be divided by the 9 or the 3/5 to the second. So you're just missing the division.
Oh, it's 18 divided by 9?
Yeah.
All right. Okay, this is, so it's 18 divided by 9? Like that?
You were right the first time. It was supposed to be 18 divided by the 2 no. 18 divided by the 3/5 to the second. So you're right the first time.
I was?
Yeah. It's the same
Oh,
like
it's 18, but it's divided by this.
yeah.
Okay, so if you have to go ahead, but I'm gonna try to finish this. This one here, we already figured out was 4/9. This 3/5 we had figured out was 9/25. And so what I'm going to do is make sure I've copied everything. The 4 divided by this, so that's taken care of, plus the 18 divided by this, that's taken care of. Addition is last. So I'm going to do this next. So this is 4/1 divided by 4/9. Okay. I can do this now or I can wait, but this is going to be 18/1 divided by 9/25. Remember, this is last. I've got it into simple fractions. Life is good. I need to convert it to multiplication. I copy the first number as usual. Division goes to multiplication, and this is the time we invert. Okay. I copy the 18/1. I change it to multiply. I invert this, or the reciprocal. And this problem is going to turn out so good in the end. Do you see how the 4s cancel? This leaves me with 9. Over here, the 9 and the 18 are fair game. And they divide by 9. So 9 into 9 is 1. 9 into 18 is 2. So this multiplication ends up being 2 times 25 over 1. 2 times 25 is 50 over 1 is 50, if that's okay, that I don't put it over 1. One more step, done.
It literally feels like we're cheating now. It's so easy compared to where
good
it
now.
was. It's like my mind.
Let me tell
I
you,
spent
I
so
knew
long
there was a
getting-
typo here because this would have been too ugly and they're not ready for too ugly yet.
I
They'll
spent
get
so
there.
long getting the wrong answer. That's why I think I'm fed up with myself. You know what I mean?
So I told this to somebody else, I'm going to tell it and then I'm going to call it. When you write down a problem, double check to make sure you've copied it correctly. Because a problem that's, see, they've made these problems so most of the time they're going to work out okay. But if there's an error in the copy, you're going to go crazy and you'll keep doing it over and over and over again. You know what I'm saying? So double check to make sure you've got it right. Because I knew something was wrong the minute I got going on that one. I could just tell there was a problem. But now this worked out. And addition, of course, is dead last. It was the very last thing we did. And it wasn't until we actually got that together and that together. Okay. So there was definitely something. So I'm going to go back. I think I'm going to stop recording. Where are we? Oh, there it is.